We are doing O-Level Additional Maths 2014 Paper 2 Question 9. We are asked to solve this trigo equation. We notice that the angle of the trigos are different and they are not like terms. So what I'm going to do is I'm going to change the cosine into sine. And to do that, I need to use a double angle formula. There are three double angle formula for cosine. The first one is 1 minus 2 sine square A. The other one is 2 cosine square A minus 1, and the third one will be cosine square A minus sine square A. Since we want to change the cosine 2A into the sine A, so we are going to target at this formula here. So I'm going to substitute that formula into here. Cosine 2A, I replace by 1 minus 2 sine square A. Now, as shown here, when the cosine 2A is changed to 1 minus 2 sine square, in this equation here, it only consists of sine term. And because of that, we can solve this trigo equation. That's the purpose of choosing this formula. Now, let's simplify the expression. Minus multiply by a minus 1 throughout. Factorize this equation. So we know that 3 sine A plus 1 equal to 0, or 2 sine A minus 1 equal to 0. So we have sine A equal to minus 1/3, or sine A equal to half. Now let's calculate the reference angle. Let's see which quadrant the angle lie. So sine A is negative. Negative, it will be lie in the third and the fourth quadrant. So now A lie in the third quadrant, 180 degree plus the basic angles, and the fourth quadrant, 360 degree minus the basic angles. So now we have the two angles for A. In this side of the equation, sine A is a positive half, so it lies in the first and the second quadrant. In the first quadrant, the angle A will be just equal to the basic angle. In the second quadrant, the angle A will be 180 degree minus the basic angle. So A will take the value of 30 and 150 degree. We should conclude our answer for the angle A starting from the smallest value, 30 degree, 150 degree, 199.5 degree, and the last one is 340.5 degree. In 9 part 2, we are asked to sketch these two graphs for x range from 0 degree to 120 degree. I would like to sketch this graph here first. Because of the negative, it will be slightly a bit more difficult to plot as compared to this. Let us focus on this half sine 3x. So the period for this sine 3x will be 360 degree divided by the number in front of the x here. So it will be 3, will be 120 degree. To plot one cycle of this sine wave, I need 4 division. 1, 2, 3, 4. The fourth division will be the 120 degree. Here is 60. And one division will be 60 divided by 2 will be 30. And here will be 90 degree. The amplitude of this half sine 3x will be half. And the sine wave will start from 0. One division later, it will go to the highest point, half. It will go down, go to a lowest point, and go back to 0. And join the points together. Now, because of this negative sign, we are going to invert this graph by doing a reflection on the x-axis. If we do a reflection, you will get this graph here. So this graph is minus half sine 3x. We are supposed to add a 2 to this graph to get the final graph that we are supposed to plot. So this point 0 add a 2 will be 2. Negative 0.5 plus a 2 will be 1.5. 0, 0 plus a 2 will be a 2. 0.5 plus a 2 will be 2.5. 0 plus a 2 will be here. And we join the points together. This graph will give us y equal to 2 minus half sine 3x. Now we're going to draw this graph here. Let's concentrate on 3 over 2 cosine 6x. So for cosine 6x, the period will be equal to 360 degree divided by 6 here. It will give us 60 degree. I need 4 division until 60 degree. So I need another 2 division here. So from here to here, it will give us 1 cycle of this waveform. The amplitude of this waveform is 3 over 2. So 3 over 2 is 1.5. We mark the point. For cosine waveform, it will go from the highest point, 1 division later go to 0, then go to the lowest point, go up to 0, and back to the highest point. If I join the points together, it will not be the final graph. The final graph, I need to add 1 to it. So every point here, I'm going to add 1 to it to get the final points. So this point, add 1, 1.5 add a 1 will be 2.5. 0 add a 1 will be a 1. Minus 1.5 add a 1 will be a minus 0.5. 0 add a 1 will be a 1. 1.5 add a 1 will be 2.5. Now let's join the points together. This graph is not complete because we are supposed to plot until 120 degree. I need to copy this graph and paste it here. Let me mark the point first. So this graph will be y equal to 3 over 2 cosine 6x plus a 1. In part 3 of the question, we are asked to explain how the solution of equation from part 1 could be used to find the x-coordinate of the point of intersection of the graph. Now we know that to find the intersection point, what we can do is we can solve the simultaneous equation. This equation is y, this equation is y, so we can equate the two equations together. Okay, we multiply 2 throughout. Bring everything to one side of the equation. Rewrite the equation so the 0 is on the right hand side. Now we notice that this equation here and the equation from part 1 look very similar. Instead of a here, we have a 3x here. Instead of a 2a here, we have a 6x here. So what we can do is, we can let a to be equal to 3x. If we were to rewrite this equation in terms of a is 3x, so 6x will be 2a. A is 3x. We notice that this equation now is exactly the same as part 1. That means we can use the solution from part 1 to solve this simultaneous equation. Okay, let me demonstrate. From 9 part 1, we have solved for a in this equation, and the value of a we obtain are all this value here. Now to solve for this, what we can do is we replace the a here by 3x here. All this value remain unchanged. And to solve for x, what we can do is every angle here we are going to divide by 3. We are moving the 3 to this side here. And this solution will be the solution for this equation here. And this equation comes from solving the simultaneous equation of the two graphs, which is the intersection points. So to conclude this question, to find the x-coordinate of the point of intersection, we divide the solution from 1. Divide this solution from 1 by 3.